Sean, you know what the word safari means, don't you?
Yeah,
Right.
it's kind of like a trip that you take, and they usually refer to it as a safari to Africa or something like that.
Usually to Africa. As a matter of fact, you're going on a safari, but you're not going anywhere near Africa. You're going into a local pond and look for animals that are far more fantastic than anything you'd ever find in Africa.
Oh, okay.
And here are the tools that you're going to need. Start here. See that?
A paintbrush?
Yes. See, when you catch a
where
little
would
animal, you can scoop them up with a paintbrush and transfer them.
Oh,
You're not going
I
to paint the
see.
animals, obviously. Okay.
Okay, I understand. And a little pick.
Yes.
Probe.
And this, when you find some animals, you can put them in there. It has a nice white background so you can see them.
Oh, I see.
Here's one of your most useful tools, obviously.
A magnifying glass.
Yes. And that magnifies 5, 10, and 15 times when you put them all together like that. Okay.
Okay. That's a little medicine thing.
Yes, ordinarily they do drop medicine, but you're going to use them to suck up animals.
Oh, okay.
And they're small enough to go in into the opening of that, too. And here's a big one.
Big
This
one.
is for basting turkeys, right, or something
Right,
like that.
okay.
But you're going to suck up bigger animals with this one.
Okay.
That, you should know what to do with that.
Tweezers. And this is kind of like a little butterfly net.
Yes, only you're going to be catching animals that are much smaller than butterflies.
Oh, okay.
Then what you want to do is go to the pond and take some of the bottom and some of the plants and a lot of the water and put it all in a tank like this.
Oh, okay.
Then let it sit for maybe a day or so, and then all of the silt and mud will settle to the bottom, and then the plants will be there, and the water. So you'll have a little cross section, a little miniature pond right like this.
Oh,
Then you
neat.
can put it and look at it very carefully with the magnifying glass. Use all those tools to take them out, the animals as you find them, and then you can put them in smaller tanks like this, and even small ones like that, and finally even little microscope slides like this made of plastic.
Oh, okay.
And here is what you really will use to finally see in great detail. Have you ever used a microscope?
No, I haven't.
Well, here's one that you can take home and practice. Take a look at that. What do you see?
It looks like some little grains of salt.
Yes, I put some salt in there so that you could get the idea.
Oh, I see. Okay.
Now, you recognize this animal, I assume?
Yeah, that looks like a dragonfly.
Well, they fly around and they eat insects and so forth. However, when you find them, they'll be underwater and they'll look more like that.
Oh, gosh.
Yeah. Real weird kind of animals that you'll
Gosh, they
find
look-
when you go on a safari in a pond.
Yeah. Ooh, it's cold.
Yeah. This is rubbing alcohol. And nurses put that on patients because they want to make them nice and cool. Now, you know why, though?
Why?
Well, whenever a gas evaporates or a liquid changes to a gas, the molecules speed up. So in order to do that, they have to get the heat energy from someplace. In this case,
My hand.
yeah, from your hand. In fact, you have a built-in thing that does exactly the same thing. It's called perspiration.
Oh.
On a hot day, you perspire, and so the molecules that fly off take heat from your body, and that keeps you cool.
I didn't know that.
Here, let's try, over here is the thermometer, see it? And there's a probe.
Yeah.
Okay, what's the temperature in the room?
19.
I can read it from the back here, 19.67, and so forth. Now, put the thermometer, well, wait. I want you to tell what's going to happen.
I think it's going to get colder.
Yeah? Where's the energy for the molecules to fly off and evaporate going to come from?
From the probe.
Right, from the probe. Okay, try it. Okay.
19, 18, 17,
Mhm.
16.
15.
Yeah, it's going
Yeah,
down
it's really
fast.
definitely going down, right? Here, I'm going to get the top of the rubbing alcohol and put it off to the side. The same sort of thing, what happened, by the way, when you touched it?
It went up.
Yeah, it's going up a little bit. No, it's still going down. 13, now it's going. Hold it real tight, and you can make it go up real fast.
Neat.
Yeah. It's a very sensitive thermometer. Now, have you noticed when you have a room air freshener or a hairspray or anything like that, when you spray it, it feels cool?
Yeah, it does.
Yeah, for the same reason now, right?
Yeah.
As the molecules are evaporating or spreading out, they have to absorb heat. Why don't you spray the probe?
Okay.
And watch. What's the temperature first?
21.3.
Okay, go.
Whoa.
They were
went
down fast, right?
fast.
Yes.
16.
This is now because when you push the top of a spray like this,
You let it-
the molecules are spreading out, right? They're going around faster, so they have to absorb the heat from someplace. Usually you can even feel it in the can many times.
Yeah.
Okay. Now let's do the most dramatic of all. Come on over here. You know what this little thing is?
Not really.
Well, it's a CO2 cylinder, and they use it to make seltzer bottles work, and they have some rifles work on this principle. Inside here is liquid carbon dioxide. If we punch a hole at the top, we're going to let it evaporate.
Yeah.
Okay, so what should happen to the temperature?
It's gonna drop.
Right, because it's got to absorb the heat from someplace. We're going to put it in that little container like that. Take that thing out, because I want to add just a little bit of water. Why would I want to put water in there? Go ahead, now put it back.
To prove that the temperature is dropping.
How are you going to tell that from the water?
It might freeze.
Yes, it freezes. If we really drop the temperature enough, we can freeze the water. So what we're going to do is put this down. There's a nail. See, there's a nail here?
Yeah.
Okay. I'm going to put the nail right on top of the thing like that. But before we push down on it, it could be dangerous. It might fly around, so put on the safety glasses.
Okay.
Are you ready?
Yep.
Okay. Push down.
Hey, you can see the ice in there.
Yeah, it's frozen right to the thing, right?
Yeah.
Don't you think that's the sort of dramatic example
Neat.
of how when gas molecules expand, they pick up the heat from their surroundings. In this case, the CO2 cylinder coated with ice.
Wow.
If you have ever seen a wild deer, chances are it was a white-tailed or Virginia deer, the most common large wild animal in North America. The name comes from the white fur under and around their tails that becomes visible when they run away. Because of overhunting, by the late 1800s they had almost disappeared from the eastern U.S. Their comeback in Georgia parallels what has happened in other areas. In the 1930s, the State Game and Fish Commission started transplanting deer from coastal regions where they had survived to other areas where they had not. License fees paid by hunters were used to expand the program. Better capture techniques were developed, like the first use of a tranquilizer dart shot from a rifle. They created clearings in the forest and planted food that supplemented natural supplies during the winter when less food was available. They also purposely set fires to clear forests of brush and smaller trees. When the plants grew back, there were plenty of tender young leaves and shoots favored by the deer. The department kept track of the animals by conducting surveys to estimate the total population. Hunting is used to keep the deer in balance with the food supply. The comeback of the white-tailed deer is an example of successful scientific wildlife management. Next time you see a deer in the wild, check it out. It will probably have a white tail.
Carol, here's sort of a fun thing to do that illustrates a cantilever, which is sort of an engineering form in which things are balanced even though they don't seem to be. And what you're going to do is balance this book way beyond the edge so that it's way beyond the edge of this book on the bottom.
Okay.
Here's what you do. Take the first book and put it over here so that it's just about ready to fall, like that, and then move it back so it isn't. Okay. Now, if you're going to take the second one and do the same thing, you can't move it over quite as far, can you? Because obviously you got the weight of both of them. Okay. Now try the third. Go ahead.
Okay.
Back up just a little bit. Okay, a fourth. Take a look, see how close you are. Almost, right?
Not quite there
Not
yet.
quite. Okay, try one more, and you should be able to get the top book beyond the bottom one. There, definitely.
Yeah,
The
it
blue
just
one is
passed.
definitely beyond it. Yeah. So try that on your friends. You can have a lot of fun with the cantilevered books. Danielle, there's a famous experiment in which, demonstration in which you put water into a metal can, put it on the stove and boil it and get it full of steam. And you put the top on. Then you pour cold water on it, and the can collapses like that. But it's sort of dangerous because you have a, boiling water. We're going to do the same thing with a plastic, 2-liter bottle and warm water. Doesn't even have to be boiling. So you take the tongs and put the tongs around there and hold it up like that so that I can put warm water in the bottle. Funnel.
The bottle's filling up with
you can see how it's hot water. So when I get it all filled with hot water and then we dump out the water, what will be left in the bottle?
Hot, moist air.
Yes. And if we cool off the moist air, the moist warm air, what should happen?
The bottle should collapse.
Why?
Because when the cold water hits the hot, moist air, that turns to cold, and that makes the bottle collapse.
Well, it'll lower the pressure inside.
Yeah.
And the outside air pressure will collapse it. Okay, now there's the top over there, see?
Yeah.
When I turn it up, you put the top on, and behind you is a tank full of cold water. I want you to put it in there, okay?
Right.
Okay. Outside air pressure then is going to put the top on. Nice and tight, real tight. Okay, take the tongs.
Okay.
And put it in the cold water. It's beginning to collapse already. And there we go. Now so this is the modern bottle version of the famous collapsing can, and this time we call it the collapsing bottle. Try this at home. Hot water and then cold water, and you can make it squash like that as though it were in the hand of a giant.
Right.
Well, Shad, you really have a beautiful little aquarium there.
Yeah.
That's really a cross-section of a pond, right?
Yeah, it's neat.
Where'd you get it?
Well, we went to the park and we found some little ponds there. And we looked around and we saw some fish. We caught some of them with the net over here.
With the net, okay.
Right.
Yeah.
We caught them, and those were the first things we noticed actually, because they were swimming around, and they,
See, one of the trouble with having fish in a freshwater aquarium like this that represents a cross-section of a pond is that the fish have a tendency to eat the other little animals.
Yeah.
If you catch any hydra or things like that, well, they'll eat them. But that's all right, that's part of the whole way life goes on. Okay, so you caught the fish with the net and stuck them in there. What else did you find?
Well, I thought I saw some caddisflies in there. I wasn't sure about it until I got them into the aquarium and looked at them under the microscope.
With the magnifying glass?
Yeah,
or
with the
magnifying
magnifying
glass?
glass, right.
Yeah. Why? What did they look like?
Well, they look really neat, actually. The one in here that you can see is covered itself up with twigs.
Right.
And some of them use pebbles, and there's
And you
leaves.
read that that's sort of specific for the species.
Yeah.
Some use pebbles, some use leaves.
Yeah.
They're one of my favorites, yeah.
Yeah, they're neat.
Then I see some other things swimming around, little tiny things zipping by.
Some little things that are like beetles.
Yeah, they're little water that live their whole life underwater, right? Yeah. Then did you use the microscope?
I did, actually. I sucked up a little fish and put him in one of these containers and looked at him. And then he looked really neat. I could see the scales and things. And when I put him back in, he kind of floated on the top of the water, so I didn't suck any more out because I thought I'd killed that one.
Well, you might have, because you maybe squeezed him a little tight.
Yeah.
But very often you have to sacrifice the animal if you're going to do some stuff with the microscope. The thing, I thought the microscope worked particularly well for you because it has a sort of built-in light source in that it takes the light via the fiber optics and runs it up, so you don't have to have a light source. Invented by a friend of mine, Dennis Brock.
Oh, that's
Yeah, well,
neat.
I have captured some animals of my own, and I think you may recognize the first one. So come on over here, and you will see an old friend. Here's my special microscope setup. Don't look at the tank,
Okay.
'cause that's where your friend is, I think. I have a card in front of the lens here, so you can't see the image, but eventually when I take the card away, the image will be recorded here by a television camera. Come around over here, and we'll see it there on my monitor.
Oh, neat.
So I'll and magnify it about 16 times. So here is your friend.
Oh, it looks like a caddisfly.
How can you tell?
Well, I can see his head and his legs.
Yeah, see?
And it looks like some little twigs on his body.
Look, I'll look going like this, and you can see. See the body all full of twigs? It has this sort of red one there, too, see?
Yeah, isn't that neat?
Yeah. So there's your friend, the caddisfly larva.
Yeah.
Now, I have a couple of others
that I collected to sort of surprise you, but it's quite typical of what you might find if you went on a safari in a freshwater pond. You recognize that?
Yeah, it looks like a tadpole.
Yeah, it's a tadpole.
But what are the little clear part along his tail?
Well, I think those are veins, probably that he uses to breathe with. I'm not an expert at tadpoles, but you can eat. Okay, then here's the eye. See it over there? Now see if we can get him to move. And there is he's got 2 legs.
Oh yeah, I see that.
There, is he? So just saw one right as he
Yeah, I
moved up.
did. Boy, that's interesting.
Yeah, and those little things that are floating around. See those?
Yeah,
They're
what
called
are those?
well, they're called water fleas. They're really Daphnia, and they're interesting animals that are very famous because you can see right through them when you look at them with a microscope.
Oh, they're transparent.
Now, here is another animal I hope you will recognize.
What is it? I've never seen something like that
I
before.
never have either, so I have no idea what it is. And that's one of the exciting things about going on a safari in a freshwater pond. You never know what you're going to run into.
Yeah. The front almost looks like it's a caddisfly, doesn't it?
Doesn't it though? Yes.
But it's got almost a shell on
But
it,
it
so
has
it
a shell
can't
on
be
it.
that.
So I call it the mysterious monster till I can go to the library and get a book and find out what it is.
Yeah.
Anyway, it's fun.
Yeah,
I've
it
spent
is.
hours and hours going on underwater safaris in a freshwater pond. Aaron, if I told you that I think you're longer than you are tall, would that make any sense?
No, how can that be?
Well, it can be. As a matter of fact, I know that you are longer than you are tall. And I have a gadget here that we are going to prove it. It's sort of like measuring, you know how the doctors measure you? And,
Yeah.
Okay, but this time we're going to start with how long you are. And by that I mean when you're lying on the floor. So lie down right here with your feet straight up now, just like you were standing. I'll put that piece of wood there right by your heels, and now I can adjust this one so it just touches the top of your head. You feel it?
Yes.
Okay. Now get up and stand on the piece of wood just like you would. There you go.
I am.
Right. Everybody is longer than they are tall. Now, can you figure out why? What is it that's pulling down on you right now?
Gravity.
Yes. And you have little spaces in the joints, especially in your backbone.
Yeah.
So when you stand up, they're all squished down and you are not quite as tall as when you lie. What happens when you're lying down?
It's all pushing down
Push
on
the other way.
The
right.
other way.
How tall is your dad?
6'3".
Standing up?
Standing up.
So if you had 3-4 centimeters or what, a couple of inches, how much do you think he would get longer when he lies down?
Oh, about 6
6'6",
centimeters.
maybe? Okay. Anyway, try it and tell him. Try it on your dad, saying, "You know what? You're longer than you are tall." See if he believes you. One of nature's most spectacular displays is the Aurora Borealis. The sky over the poles glows red, white, and green when particles spewed out from the sun are captured by the Earth's magnetic field and collide with the gases in the upper atmosphere. To study the aurora, University of Alaska scientists have their own rocket launching program. Watch. Rockets are used for gathering some of the data because the lights occur at altitudes that are below the orbit of an Earth satellite. They also launch instruments in balloons. This field of sticks and wires is an antenna of a new radar that can continuously monitor the winds high up in the atmosphere. You can see auroras further away from the poles on rare occasions when the sun's storms are extremely powerful and many more particles than usual are given off. An example of how the sun affects our planet, the beautiful lights in the sky, the aurora. Think it'd be possible for you to smile at the same time as you're standing there?
Yes.
Fire? Huh? Think so?
Yes.
All right, here we go. Wouldn't you like to know why I took that picture of you?
Sure.
I'm not going to tell you, because I have another challenge for you. On this table is an example of the fourth dimension, and I want you to try to find it.
Okay. Well, there's the ruler, the piece of string, the notebook, the map of North America, a measuring glass, sugar cubes, a box of them, a toy fridge, and I guess a record player.
So where's the fourth dimension, or example of it at least?
I don't know.
Well, let's start with one dimension. Here is an example of a one-dimensional object. Even though a ruler has 3 dimensions, we only use it to measure 1 dimension, which is usually what?
The length times...
The length, right.
Yeah.
Okay. So then here is another example.
It's a string.
Right. And we usually only think of it in 1 dimension, although it obviously has more than that.
Yeah.
So now you get the idea. That's 1 dimension. Add 1, what do you got? 2 dimensions.
2.
Okay.
Well, the notebook, the length times the width.
Right.
And then, so that's the second dimension,
Right.
2.
Right. And?
Well, the same with the mat. The length times the width, and then it's another example of 2 dimensions.
Well, there's another 2-dimensional aspect of a map, too. They have longitude and latitude in order to find your way. And a street map has the same thing, doesn't it?
Yes.
Okay. So after 2 dimension comes?
3 dimensions. Well, I guess the measuring glass, for volume.
For volume, right.
Yeah.
And?
A sugar cube.
A cube. That's one of the reasons I put it here, because a cube has 3 dimensions, which are?
The length times the width times
the height. Right? So does the whole box.
Yeah.
So very often you buy things now because of their volume, like peck and quart and so forth, and meters, cubic meters and so forth. Refrigerator, how do your parents buy a refrigerator?
Obviously by the volume.
By the volume, right.
How
And the
much
bigger it is,
holds.
why the more it costs, right?
Yeah.
Okay. So what's left? This.
Record player.
Well, here, I'll give you a clue. You should be able to recognize.
The only thing I can recognize...
Wait a minute. Hold it. What?
Well, the only thing I can recognize from it is that it's playing faster than it should.
Yeah, it's going too fast. That doesn't give you a clue? Okay. Now, remember, I took a picture of you when you came in?
Yes.
Okay. Which one is you?
How'd you get my baby picture?
Yeah, I got it from your mother. I told her we needed it for a scientific experiment. Any difference between the two?
Yeah, well, her hair.
You have more hair, right?
Yeah, a lot more
Clothes
hair.
are different.
The clothes.
When were the pictures taken?
Well, that one obviously a while ago.
Yes.
And
this
one
one,
a short while.
So you notice how people put the date on the bottom of pictures? Why do they do that?
To tell when you took the picture.
Yes. And so what is that 4th dimension?
Time.
Time, right. Now, you can see why I played these at a different speed?
Yeah,
that was the difference. In fact, refrigerators even, and various other items in everyday life, time is important. You can buy a real old-fashioned refrigerator, right?
Yeah.
So they say in the ad 19, such and such model.
Yeah.
Well, you've done very well. Would you like an apple? You like apples?
Yes.
All right. Here you are.
I'm not going to eat that.
Why not?
Well, it just happens to be rotten. It's an old.
Why do you suppose I offered you a rotten apple?
To show me the time difference from a new apple to an old apple.
So you buy fruit and vegetables, don't you, based on how fresh they are.
Yeah.
So time is important. Well, I've actually got a real apple because you were very good. It finally recognized, what is the 4th dimension?
Time.
Have an apple.
Thank you.